Hello, everyone. Good afternoon. Thank you all for joining the session. The session will be hosted by Mehul Lad, FMEA lead at PI-EV 2022. Mehul, if you're ready, you can begin with your presentation.
Okay, sure. Thank you so much, Christy. I'll just share my screen.
Sure.
Is my screen visible to everyone?
Yes, Mehul.
Okay, cool. So hi everyone. Good afternoon. So today we'll be discussing about the FMEA and whatever doubts you have with respect to FMEA. Before starting with the Q&A session, I'd like to go with a very small introduction about myself. So myself, Mehul Lad, and I've completed my bachelor's from DJ Sangvi College of Engineering, and I was a part of DJ Racing. After DJ's Racing, I joined Formula Bharat and Furosium Tech as the reviewer lead for FMEA, and then afterwards, I was also the EV scrutineer for the Formula Bharat 2021, which happened. And now I'm also the FMEA lead for IEV, which was earlier the FSEV Concept Challenge. So this was all about myself and my along with Formula Bharat, whatever I've read. So let's start with the introduction about FMEA itself. So I'll go and show you guys the different points which we consider while reviewing the FMEA. So you guys will have a brief idea, and then afterwards, you guys have any doubts and questions, you can just ask me about it. So starting with the very first question about FMEA is like, what is an FMEA? So FMEA is basically a structured documentation which helps us in like understanding uh, what are the different concepts and how to go ahead with designing a particular vehicle. So first of all, FMEA stands for failure modes, effects, and analysis. So discussing failure modes is very important whenever you are designing something or you're trying to manufacture something, because if we know how a particular component is going to fail, then we can provide a way around to that particular component or a particular design so that it is robust, and it will help us in like the during the whole manufacturing process. So thinking about the failure modes during your design process is one of the most important concept while designing your electric vehicle. So with respect to Formula Bharat, FMEA is a document whose template is provided on the website itself. So it basically consists of almost all the components which are there in the electric vehicle, which are expected in the electric vehicle developed by the students. It includes everything right from your tractor system wiring till your shutdown circuits and whatever safety systems are there required for your designing. Apart from that, if the team wish to add some components and get it reviewed by us, let's say a team wishes to use a DC-DC converter, or let's say some BSPD circuit externally, so that you can add to this FMEA, which will be reviewed by the reviewers here at the Formula Bharat and even at the 5EV during the 5EV concept challenge, which can help you guys while for designing the vehicle. So the whole purpose of this concept challenge is to so that you guys could have a brief idea how to design an electric vehicle. So if you are planning to use any kind of new systems which is apart from your rule book, I will suggest you guys to put it in your FMEA. I know FMEA is code, and also you might ignore the not necessary things in your FMEA, but the major point here is to manufacture your vehicle. So it's better to get it reviewed from us during this process. So yeah, this was about FMEA. Now talking about how to approach, like how to learn writing your FMEA. So we'll start by a simple example of a tractor system wire, which is a very basic component in your uh, electric vehicle. So I'll give you some options in this particular wire, and we will find out that how exactly by answering to very simple questions, logical questions, we can design the FMEA. So many times students tend to get confused while writing the FMEA. They go through the different jargons of the FMEA, such as severity rating, occurrence rating, detection, and all. So in that, they get confused, and they just try to, in the end, they just try to fill whatever they like, and it is not at all related. So it's better to go through your simple questions, which I'll mention now. And these questions are very important, not even for designing your FMEA, but also for manufacturing your electric vehicle. So let's try to go ahead and answer those simple questions. So there are five basic questions which you need to answer. Is like, let's say you're talking about a tractor system wire. So the first question will be like, what is the function of a wire? What does a wire do? These are very simple logic questions. The second is like, how can a wire fail? And if a wire fails, then what are the causes of its failing? Then how will it affect the system if a wire fails? And finally, how can I prevent it during the design process? So these are somewhat some basic questions. And once you know that how you prevent the failure of your wire, then you also have to understand that how could you come to know about the failure, because in order to prevent the failure, or sorry, even if after preventing the failure or making changes in the design, but let's say the failure happens, you should know about the uh, failure if it happens again. So let's answer to this question. Talking about the function of wire, we know that a wire is helpful in transferring the energy and finally to provide insulation. So if a wire's function is to transfer energy and provide insulation, and the wire fails, so what it will do? It will lose its ability to perform the function. So that is what is the way where wire can fail. There will be no power transfer or no energy transfer, and otherwise there will be less power transfer. So this is the option where wire can fail. Otherwise, what will happen is like what then now talking about this, if the wire has failed, now what are the causes of the wire failing? So the wire can fail because of two reasons: either the wire has bricked, or there is a disconnection between the wires, or else it's a short to an external circuit, hence there is no transfer of power happening or energy transfer is happening. So that are the causes. These are the two causes for wire failing. Talking about the effect, so now when you talk about the effects, you need to consider the whole scenario, like with respect to your car. So the purpose of wire was to provide the energy. So in terms of wire also, you have to find out what are the effects. Like if the wire is broken down, what which systems are going to be affected. Like let's say a wire is connected from your accumulator to the motor, and the wire has broken down. So the effect is that there is no energy transfer from your accumulator to your motor. So that is in terms of wire. Let's say we are talking about in terms of signal. So your different components which are associated with your motor, let's say your pre-charge circuit, your uh, discharge circuit, your discharge relay, they won't get the proper signals. So these are all the local effects which you need to mention when you are talking about a particular component. Whatever the function a particular component does, the output of that function, if it is going to some component, different component of your vehicle, so that will be affected by the a component, first component. So you need to mention in the effect that this component was getting affected because of the failure of a component. So these are the effects which you need to mention. And finally, if you want to prevent the failure, so either you can like prevent it during the design itself by saying that the quality of wire, you should choose a good quality of wire. If you have a robust quality of wire, then it won't break easily. So depending on your current calculations and other calculations, if you choose considering proper factor of safety, if the wire is of good quality, then the breaking of wire will be, the occurrence, like the frequency of wire breaking will be less. So that is how you can prevent it during the design. And finally, how would you come to know about the failure? Is like either if it's a if it's breaking of the wire, then it will be basically exposed terminals, and there will be some sort of loss of isolation, though IMD might detect it, or otherwise it will be through an overcurrent. So let's say your wire has got shorted to an external circuit, so there will be overcurrent, and then your fuse might break, and that will result in you in coming to know that the wire has failed. So these are the simple questions which we have answered here. We didn't went through the definitions and names mentioned in the FMEA. These are very simple questions which we should know while we are using a particular component in the vehicle itself. So that is how we understand, or that is how we select a particular component before using it in the vehicle itself. Now, talking about how answering these questions will help us in designing the FMEA. So when I was talking about the function of wire, that is the very first column of your FMEA. That is your product which you are using. Then we thought that how would a wire fail? So we thought of that the function of the wire, which wire does, it won't be doing that function. That is your failure mode, the second column of your FMEA. The reasons why we thought that the wire would fail is either it would have been breaking of the wire or an open wire condition, or either it would be shorted to some other circuit. So that is the cause. And then finally talking about the effects, where, as I mentioned, in terms of wire or in terms of signal, whatever effects you can put in, you can put it there. So keep in mind, when you're talking about effect, there are two types of effect: local effect and global effect. Local effect is with respect to a particular component. Let's say you're talking about the wire, whatever wire is connected to the systems which will be affected with this, with the failure of the wire, you need to mention it in the local effect. Then when you are talking about the global effect, you should consider the whole car while talking about the global effect. So let's say a wire is connected from accumulator to motor controller. So breaking of the wire is going to affect the motors and the motor controller itself. But as a whole, the car will stop. There might be some other hazardous effects such as thermal runaway due to shorting. So that is what you need to mention in the effect, global effect itself. So considering the whole vehicle as a system is your global effect, and considering small systems to which that individual component is connected is your local effect. Then we talked about how would you prevent the design. So when you find out the mechanism to prevent a particular failure, apparently the occurrence, that occurrence is basically the frequency of that failure happening is lower. Basically, if you have a good design that would prevent a particular failure, the occurrence of that failure to happen is very low. So that is your occurrence reasoning. And finally, detection is basically how would you come to know about the failure. I guess that is how you design your FMEA, by answering this simple questions, which these questions, as I'll repeat again, that these questions are very important while you're even trying to design your vehicle or manufacture your vehicle. So answering these questions is must before even going for your design process for each individual component present in your system. Then we'll talk about the different definitions which are present in the FMEA. So let's talk about the remaining three columns. So up till now, you have completed your 90% of FMEA. That is just by answering to these simple questions. Now the remaining two, three things we'll discuss. Before that, I'd like to let you know that while you are designing your FMEA, the causes which you mentioned, so there must be some interrelation between the columns. It should not be like you are mentioning some three causes for wire, and the occurrence and detection you are mentioning is for some different uh, reasons. So let's say, for example, if your failure cause, or let's take a different example. We'll talk about a pre-charge relay. So you have a failure that your pre-charge relay is not working, or your pre-charge relay has failed. So what will be the causes? The causes will be that either the relay is not of appropriate rating, or might be the resistor which you are using for the pre-charge process is not of appropriate rating. So if you're mentioning these two causes, the causes are related to your pre-charge relay being not of appropriate rating and your pre-charge resistor not being of appropriate rating. So your occurrence is basically what the prevention measures which you will put is should be related to the relay and resistor itself. No, nothing else. So whatever the causes you put, the occurrence should be directly related to them. So when you're talking about occurrence or the preventive measures, you should tell that we'll use a proper rating relay, or proper calculations of relay would be done. So in that way, you have prevented this failure to happen, and hence my occurrence rating is so and so. If you're talking about pre-charge resistor, then you should mention that you are using a proper resistor of this rating, and hence the occurrence or the failure, the chances of this failure happening is low, and hence this is my occurrence rating. And if you haven't considered these causes, let's say you have mentioned that pre-charge register and pre-charge relay are the causes. So if you don't have any proper preventive measures of the failure, then you should mention that no, this is not considered, hence the occurrence might be high. Or the rating which you have to put is dependent on what preventive measures you have mentioned in your occurrence reasoning, and the occurrence reasoning should be directly related to the causes which you have mentioned. So in this way, cause and occurrence is directly related. The same way, detection and cause is directly related. So detection mechanisms should be such that they directly pinpoint to the cause. So as we were talking about the wire broke down or the wire is shorted to the external circuit. These were the two causes. Now in detection, if you just mention that the overcurrent will happen and we will come to know, but then this is not the proper way, because there are two causes. Either it's an open terminals or it's a shorted circuit. So overcurrent can happen due to multiple reasons. It is not just because of the wire breaking down. There might be some other reasons which might lead to uh, overcurrent situation. Hence, you need to mention some different detection mechanisms such as IMD. So with the help of IMD and also the overcurrent mechanism, we can directly pinpoint to the failure cause that the wire have shorted to an external circuit or the wire has some exposed terminals. So with different detection mechanisms, the detection of the failure mode is more. So the number of detection mechanisms you have, the number of detection reasonings you give, on the basis of that, you should provide the detection rating. If your detection reasoning is not covering all the failure causes, then your detection rating should be high. Basically, there is more chances, or there is less chances of detecting the failure. I hope this is clear to you guys. So basically, failure cause and detection are interrelated, and failure cause and occurrence are interrelated. Then, talking about the severity rating, which is another column in the uh, in your FMEA. So most of the teams tends to do a mistake for severity is that they consider their detection mechanisms in their severity, and they give the ratings accordingly. So let's say your wire is broken, you have exposed terminals, and then your shorting has happened. But then you mentioned that IMD would detect this failure and open the shutdown circuit, and severity is low. This is not allowed. You should keep severity and detection mechanisms completely different. Severity should be directly related to your failure effect, whichever you have mentioned for the failure cause. So for the failure mode. So if your failure mode leads to a local effect of affecting your systems and a global effect of a fire, so then severity rating should be according to it. One more thing about severity rating is that if fire and other thermal runaway are your effects, so severity rating is not necessarily supposed to be the highest. You need to consider some different facts such as the time to react to that particular effect, the presence of driver in the system or not, and if the driver is present, will he be wearing, so he must be having his suit which might help him to get away from the situation. So these are the certain facts which you need to consider while putting out your severity reasonings as well as the rating. So I'll repeat, severity ratings and severity reasoning should not consider the detection mechanisms, but they should consider the facts such as time to react to a particular effect, the presence of driver in the system, the presence of people around the system, and how it is going to affect the people around the system. If it is going to lead to a huge fire and it might cause some fatal injuries, then you can put it as severity rating as high. But if no one is around the system, if the driver is the only person in the system when this failure has happened, so does driver have the time to get out and run away from the system? So this things you need to consider while putting your severity reasonings as well as your severity ratings. And finally, talking about the last column, that is failure handling. So failure handling is further divided into two parts, that is failure handling by vehicle and failure handling by team. In failure handling, you just have to mention how the vehicle will react to the particular failure, Like what are the systems installed by in your vehicle which will react to a particular failure. Let's say any failure has happened and your vehicle will shut down automatically. The shutdown circuit will be opened. AMS will detect the fault and AMS will shut down the system. The effect of your detection mechanism should be mentioned in your failure handling by vehicle. So if a particular AMS fault has occurred and AMS has failed, so during that period, what will happen to your vehicle? That is what you have to mention in failure handling. And while talking about team, you need to describe the exact procedures which you will use to uh, handle this particular failure. When I talk about exact procedures, you need to mention about the number of people involved during this process, safety tools which will be used, and the steps to follow the steps you would follow to find out the failure. So let's say your there is a fire in your accumulator system. So during that point, how many people will be working, how they will be working, what safety tools you guys use, what are the safety precautions used by your team, some rules and protocols which are followed by your team, and then finally the steps which your person who is working on the system to find out the fault will be using. So that is what failure handling, that is what is expected when you talk about failure handling by the team. uh, Finally, I would like to say that do not copy your FMEA, because copied FMEAs are clearly visible, and at Formula Bharat we do not accept copied FMEAs. We directly reject those copied FMEAs. That's it from my side. Thank you. So if you guys have any kind of doubts, you can now ask me. Uh,
Hey Mehul, there's a question for you on YouTube. It says, can you please put some light on failure of tractor system active light?
So our failures of tractor system active light. So what light exactly? So this is something which you guys have to think about. So let's say I have to talk about tractor system active light. So I'll consider, as I mentioned, you need to answer the simple questions which I discussed earlier. So as we talk about we should understand the function of the TSL. So the function of TSL is to show the status of the vehicle, right? So if it has to fail, so it will fail by not showing the status of the vehicle, or it will malfunction by showing the wrong status of the vehicle. So once you know the failure, now you need to know the cause for it. So let's talk about the causes. So causes will be like either the signals received by the TSL are not proper, so there is some circuitry issue. Secondly, either the wire which is connected to the T cell is shorted to some ground or shorted to some supply, so that's why it's not showing the right signal. So these are the two causes which I can find at the top of my head, but there are multiple causes which you can go for T cell. Either the lights which you use for your T cell are damaged, or they are not proper rating. So that is one of the causes. Once you know the cause, now you need to know the effect. So effect will be like your system won't be having a proper idea what is happening. So you would consider TS as deactivated, but TS might be active. That is your local effect. The low voltage the global effect will be that this would lead to some, so your team members would take some procedures considering that TS is activated but it was deactivated, so that might lead to some hazardous situation. That is the effect. So this is in a very general term what I'm talking about, but you need to be very specific while you're talking the effects of the TSL or any other component. When you say that it will be hazardous, you need to be very specific that how exactly it will be hazardous. That is what you guys have to think about. Then talking about after effect, let's say occurrence. So occurrence is basically preventive measures. So preventive measures will be that whatever the systems or whatever the circuits you have designed are proper, they are robustly tested. There are some sanity checks which you guys have put in your T cell circuit so that there won't be any kind of circuitry errors in during while talking about the T cell. And then afterwards, the lights used for T cell are of appropriate rating. The wires used for T cell are of appropriate rating. So whatever the causes I've mentioned for the failure, I'm talking about the preventive measures with respect to the causes itself. So number of causes you mentioned, then afterwards you will be talking about the uh, preventive measures, and then finally severity will be according to the effect, and then failure handling by your. I hope that clears your doubt.
All right. Thanks, Mehul. Um, there are some new questions that have come up on the form.
Hmm.
Are you viewing the form right now?
No, just a second. I'll be.
Yes, sure.
There is one question on Zoom itself. What should we answer? So I didn't understood what Vishwa Races Electric has. So if you could just open your mic and talk, it will be much better. If that is fine. Crystal, is that okay?
Yes, that's absolutely fine. Uh,
Vishwa Races Electric, you can like turn on your mic and
Hello, sir.
yeah.
So the question was, suppose there are severe issues like if controller fails, so there are LEDs to detect to indicate the errors.
Okay.
So my question was, what if the controller fails and within the same way the LEDs
Yeah.
also fail? So we would not be able to detect the controller has failed because the LED is not also indicating. So what would be like
Hmm.
reason for the detection?
So when you're talking about a failure mode of a particular component, so you're talking about controller itself. So you should consider the detection mechanisms which you have used for your controller. So let's say you have LEDs for detecting failure modes of your controller. So you should just mention those detection mechanisms, and you should also include some more detection mechanisms for the controller. When you will be talking about LED as a component, so that time you will discuss the failure modes of that LED. But for controller, you should just keep the detection mechanisms. So don't consider two failure modes at a time. Be specific to one component itself. You're talking about controller, so talk about controller itself or mention about controller itself. Now, this is a valid point that LED used for detecting the failure modes of controller might also fail. Then your detection mechanisms are not enough to detect the failure mode of the controller. So your detection rating will be high. So it is not good. It is not a good rating. Basically, what I'm trying to say is that the failure mode is more prone to happen, and you don't have a proper detection mechanism in your systems to detect that particular failure. So you need to include some more detection systems in your vehicle apart from that LED. Then your detection rating will come low. Uh, was I clear about it?
Yes, sir. Yes, sir.
Okay. Uh, What is the failure cause? So now, so this is something which you guys. So I am getting a question from Mohammed Arif. Arif, yeah. So his question is like, what can be a failure cause of a faulty encoder? So my point is like this causes you should consider, you should find out. This is something we have given you the task to find out. So it won't be like we can't spoon feed you the causes. Come up with your ideas, come up with your answers, whatever you think of, then we will review it, and then afterwards you'll get a proper feedback to it. So that's the whole purpose of doing this FMEA task, so that you guys can find out the answers to these questions. I can help you with the definitions and the structure of the FMEA, but the answers, direct answers to the questions, you have to find to them. So I can't answer this your causes direct. That's why. Then second question I have is if Arif, you are on this call, then you can like discuss whatever doubts you have, but direct answers I can't give you. Yeah. How is the FMEA? Huh. Okay. So there is one question from Ankit Parasha that he wants to know how is the FMEA evaluated. So as I mentioned, while evaluating the FMEA, first thing you guys need to keep in mind is there is no correct rating to any column. There is no perfect rating to any column. What we are trying to do here is finding out that how logically you are thinking, what reasonings you are providing. So rather than the ratings column and the RPN number you calculate, the reasons you provide to those ratings that are very much important to us. So let's say if you are considering a failure mode of a tractor system active light or a failure mode of your wire, so you need to be very sure that you consider all the causes. Think it through. The most of the teams try to put one cause, two cause to a particular component, and they finish the whole row. That's it. But there can be multiple causes to a particular failure mode. So try to think it through, find out the different causes. Every cause is what you can find, and then afterwards try to evaluate those causes in your particular row by filling out the different columns. So let's say you have four causes for a particular failure mode, and we find that this is enough. This is something which you have thought of, you have gone through everything and then found out these four causes. Then we rate it accordingly, we give them full marks or whatever the evaluation process is. But for us what matters is the reasoning which you provide, the thinking process which you use for the for filling out the FM. I guess, Crystal, I'm done with the questions. There is one question, but I don't think so. It's related to FM.
All right.
It's yeah.
Okay, perfect. Team members, if you all have any questions, feel free to unmute and you all can ask your questions now. Mehul, we'll just wait for like a few more minutes to see if any more questions are coming in.
Yeah, sure.
Okay, there are a few questions on YouTube. I don't know. You can judge if they need to be answered. The first question is, how is FMEA evaluated?
So I actually recently answered the same question. The basically evaluated in the sense if they want to know the direct process of scoring. So that is something we can't answer for now. But then that is what they'll get a feedback accordingly. So if I have to give you the overview of the scoring process, is just that as I mentioned earlier, the number of causes you put and how you provide answers to those causes. So basically, if you have provided four causes, first we check that how many causes you have provided. You have provided four causes for a particular failure. Now we think that if this is correct, that these four causes are perfect to this failure mode, there can't be anything else. So we give full marks to those causes. Then afterwards, we find out the how you have related those causes accordingly in your different columns of a particular row. So as I mentioned earlier, your causes should be related to your occurrence and your detection mechanisms, and your effect should be related to your severity. This is the first key point which you need to consider. And second is that whatever causes you are mentioning, let's say you have mentioned four, all the causes should be covered in the rest of your columns. So your detection mechanism should have detection systems for all the four causes. That's it. So if everything is covered, then that particular row is given full marks. So accordingly, all the rows are evaluated.
All right. The next question is, for sensor is broken failure mode. Does that mean that the sensor cannot work, or does that mean sensor sends the wrong value?
Uh, Crystal, I'm sorry, I lost your voice in between. Could you repeat the
Okay.
question?
It says for sensor is break for sensor sensor is broken failure mode, does that
Yeah.
mean the sensor cannot work, or does that mean that the sensor sends the wrong value?
So sensor is broken is basically that the sensor is not working for now. So that is how you interpret it. Sensor is broken is basically sensor is not connected it to the system. That's what it means.
All right. The next question is, for signal connection is broken failure mode. Does that mean the physical connection do not send a signal, or does that mean the connection makes ECU receives wrong signal?
Any broken connections or signal connection is broken is basically the, so it is actually the way you interpret it. So if you feel like there are two ways this particular failure mode can be interpreted, you can add a row at the bottom and then you can mention it, whatever the so the other thing. So for us, we consider it that the physical connection is broken, but if you feel that this can also be the interpretation of a particular failure mode, you can add the row to the bottom, that will be evaluated. But for in general ways, any signal broken or any broken failure mode is basically the physical connection being broken.
Okay. The next question for you is, what parameters we need to consider firstly for the motor controller failure?
Parameters to consider for motor controller failure.
Yes.
So there are okay. So there are multiple parameters you can consider. It's depending upon the so motor controller failure mode also has different sections. So you need to go through the particular section, what type of discussion is going on. So if it is related to a signal to the motor controller breaking, or if it is related to the functioning of a motor controller, or if it is related to torque output is being broke, torque output is not proper. So considering the exact failure mode, you need to consider the causes. So there are multiple parameters. Find out the functioning of your motor controller, what your motor controller does, whatever the different functions your motor controller does, just reverse it, that it won't happen. So that is your failure mode for your motor controller.
Okay. The next question is, while talking about the failure handling under the actions taken by the team, does it also contain the steps that the driver may undertake on track, or only the steps taken by the team at pit?
No, if it's always good to include everything you can. So if the failure mode is about something which is happening on the track, then how is your driver going to react to it? If you could mention that, then it will be good for your scoring process.
Okay.
So yeah, it should
Um,
be included.
all right. Another question for you. What is the format to fill revision page in the template?
So I guess it is mentioned in the template itself. Otherwise, you have to basically whatever the changes have been asked to you, you need to color those columns with red, and then afterwards you also need to add a template where you need to like a blank sheet where you need to mention what at which row at which column you have made the changes. This is the two process we follow, and apparently every reviewer who is reviewing your document will communicate with you whatever the way he likes. But generally, we follow during FSEV or PIEV, we follow coloring the changes. So let's say we have asked changes in particular section, so you need to make those changes and color everything red. Then we will evaluate the process, evaluate the FME, and then remove those red colors in from your document. And also, if particular reviewer wants the extra sheet where everything needs to be mentioned, so that will be communicated you via the review.
All right. Another question that has come in is, should internal failure modes of OEM parts also be included in the list?
So it's up to the team. First of all, the FMEA template includes everything from the rule book, which is a necessity for designing the vehicle. Apart from that, if a team wish to get evaluated any of their OEM components, they can put it in their FMEA, and it will be evaluated and feedback will be provided accordingly.
There's one more question for you. If we are adding more than 118 failure mode, is it being calculated also into FMEA score? And what score difference if we decided not to mention those failure mode are the 118 point?
No. So as I mentioned, the 118 points will be the ones that will be scored. Apart from that, anything added will be just to help the team in their designing process. So whatever the template we have provided, that is going to be scored.
I guess those are the only questions, Mehul, on YouTube. Um, okay, there's another question. Does the AMS failure can affect the other systems of the car?
So it depends on your design. Like if your AMS is connected to some other systems, which if you are using the signal of your AMS for some other systems, then yeah, it might be affecting the car. But in general terms, AMS is like, according to the rule book, the AMS systems is basically connected to the shutdown circuit. So if AMS fails, your shutdown circuit must be affected. That's the general thing. But if you are using your AMS signals to other systems, then yeah, it will be affected.
Mehul, we'll just wait for 2 more minutes. If any more questions
Yeah.
come in, we'll take them.
Also, like if anyone's question is not like answered properly, so they can comment again. You can have a discussion.
Okay, there's one question. What is the difference between failure detection and detection reasoning?
So failure detection is basically the component or the tool basically the component which is used to detect the failure, and detection reasoning is like how that particular component is going to help detect the failure, and also secondly that how your detection mechanism is effective in detecting your failure. So let's say your AMS has failed and you have used some, let's say IMD is the component which is detecting your failure. So failure detection should provide the component along with the reason that how exactly IMD will be detecting that failure of AMS. Now your detection reasoning should include how the IMD as a detection mechanism is detecting a failure or pinpointing directly towards the AMS failure, and on the basis of that detection reasoning you will be providing a detection rating that yeah, so how easily IMD is going to pinpoint to the AMS failure, and that will be your rating accordingly. I hope it is clear.
Um, okay, thank you, Mehul. I think those are all the questions for today. Um, looks like we can end the session now. Uh, all right. Thank you, Mehul, for making the time. It is a pleasure to have you hosting this session and answering all the queries that the students have. Also, thanks to everyone who has joined in. In the case any of you all have still have any queries, feel free to write to us. And thank you all once again and have a great day.
Thank you very much, Christy.